Hi everyone, welcome back. Today we are solving construct the minimum bitwise array 1. So we are given an array nums consisting of n prime integers, and we want to construct an array answer of length n such that for each index I, the bitwise order of answer array of index and the answer of index plus 1 is equal to nums of that index. So in other words, we will take this, use the bitwise OR operation with this number, and it must equal nums array at that index. And we also want to minimize each value of the resulting array, or in other words, to return the minimum number that satisfies this condition. And if it's not possible to do that, then we will return -1. So if we look at this example, 2 is impossible, so we put -1 for that part. 3, the minimum number will be 1 because 1 OR with 2 will equal to 3. For this one, the minimum number would be 4 because 4 OR 5 would be 5. And for this one, the minimum would be 3 because 3 with an OR operation with 4 would make it equal to 7. And for this example, it would be 9 for 11, 12 for 13, and 15 for 31. If you're not sure how we can calculate the OR operation, don't worry, we will go over in the example walkthrough. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can iterate through each number from that array, and for each number in that index, then we can check from 1 to that number to see if any number will match the condition where that number with the OR operation of that number plus 1 will equal to the number at that index. And we want to add the smallest number that matches the condition to the answer array, and then we will return the answer array at the very end. Now, if we do it that way, the time complexity would be n times m, where n is a number of elements in the array, and m would be the largest number in that array because this will be a number of numbers we'll iterate through, and within the number, it can take up to this much time to check from 1 to that number. So there is a more efficient way to solve this problem, and we can go over that way right now. So this will be the number we're given, and this would be the solution for that number. And I hope you guys notice a pattern. So basically, the solution, we are always taking the original number, subtract by wherever the first 0 is located, looking from the right, and it will be 1 digit to the right of that. So right here, the 0 is here, so we will subtract the 1 here, and right here, the 0 is here, so we will subtract 1 digit to the right, and right here, the 0 would be right here, so we will subtract 1 digit to the right. Now, I did lay out the steps to solve this problem, but honestly, it's kind of hard to understand by just reading it, so I will focus more on the example walkthrough and the coding part. But basically, we'll iterate through all the numbers, and for each number, rather than needing to check from 1 to that number, we can just check its binary digits and using the left shift. So 2 to the 0 power is 1, 2 to the 1 power would be this, 2 to the second power would be this. And when we get to when we are checking its digits, whenever nums of I with the AND operator with digit is equal to 0, then we will set the number to nums of I, subtract by the previous digit, and that will be the number we add to the resulting array, and we'll return the resulting array at the end. So let's go through this example real quick. So the first one, the number 2, it does not have any number that satisfies the condition, so we add -1. Move on to the next one. When the digit is 1, it does not make it 0, so we go on to the next one. When the digit is 10, or number 2, it's not 0, so move on to the next one. And now when we set it to 4, then it is 0, so we will do 3 minus the previous digit, which is 2, is equal to 1, so we add 1 to result. Move to next number. For 5, when the digit is 2 to the 0 power, it's not 0, so move to next digit. Now, when we move 1 to here, it is 0, so we will do 5 subtract by the previous digit, which is 1, and that's 4. So we will add 4 to the resulting array. Now move on to the last one. When the digit is 1, it's not 0, so move on to next power, still not 0, next power, still not 0. Now when we set it to 8, it is 0, so we will do the previous digit, which is 4, and 7 minus 4 is equal to 3, so we will add 3 to the resulting array, and we can return this as our result. So the time complexity would be O of n log m, where n is the number of elements in the input array because that's the number of elements we'll iterate through, and m would be the largest number in the array, but we are iterating through its digits, so it would be log m instead of just m, and the space complexity would be O of 1 because this does not count as extra space since we are returning it, and the size of these variables will not depend on the input of the problem. So now let's get to the coding part. So first we'll initialize the resulting array and we will iterate through nums. So for I in range length of nums, initialize number to -1 and digit we will start at 1. And now we'll set a while loop. So while nums of I and digit does not equal to 0, then we will set number to nums of I minus digit, and we will left shift the digit by 1. So we will do digit with the arrow to the left and 1. And after the while loop, we will add number to result. And after the for loop, we can return the result. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.